All right. So, very good evening to all. I welcome you all in this live tutorial session number 11. And in today's session, we are going to see about the distributed generation, and then we will see the concept of microgrid. So that is part of our active distribution network. Means nowadays we know that due to renewables, this the integration of DG is increasing rapidly in our distribution network, and then we have the concept of microgrid comes into picture. So we will all see about today mainly the distributed generation, or we call it as DG, and then we will see about the microgrid concept. So let us begin the sessions. But we will see before that we will see about the reconfiguration of power distribution network in a very short. So what do you we have also discussed this reconfiguration of power distribution network in the last session, and in today's session we will just quickly revise this. Means what is the meaning of it, and what are the optimization methods, and what are the solution strategy, and what are these objectives in the reconfiguration of power distribution networks, and what are maybe the constants in this uh, optimization objectives. So reconfiguration is, means that to change the topology of a network, means to change the topology of power distribution network, and this configuration may be varied with manual or automatic switching operation. So the change in network configuration is performed by opening, sectionalizing switch or tri-line switches. So we know that we have two types of switches in our power distribution network. One is sectionalizing switch, they are normally closed type, and other one is tri-line switches that they are normally open type. So basically tri-line switches are used to connect the uh, two parts of network that are feeding through this feeding through different feeders, and this sectionalizing switch we are using to remove the faulty parts. So the reconfiguration basically means that we are reconfiguring the network in the existing network. So we are not developing a brand new network. What we are doing all in the existing network. So it is not a expansion problem. It is not what means we have already provided the distribution network, and we are changing the topology of network such that our some objectives will be fulfilled. So while fulfilling the objectives for reconfiguration of our distribution network, there are two constants shall be met. So these are two constants, means while doing the configurations. First is that all demands shall be met. You are not allowed to you are not allowed to just power cut some power some demands, and the redundancy of network shall be maintained. So these two constants should be fulfilled while we are doing the reconfiguration. These are must satisfied constants. Now, what can be the optimization objectives for optimal network configurations? So there may be different objectives, and these are like maximization of service restoration, or you can see it. Then you are you can say in other words like maximization of reliability or minimization of service interruption. And the other objectives may be like energy loss minimization, feeder load balancing or transformer load balancing, prevention of transformer and feeder overloading, minimizing switching cost and number of switching, and maximization of voltage stability index. So there may be many objectives for your power reconfiguration problem, and these objectives may be like this one. There I have uh, written down. So you can see that in these objectives, you are not there is no any objectives like that. You are expanding the network. You are developing a new network. In these objectives, you can see that you are doing or playing with the switches in the existing network so that these objectives can be fulfilled. And now these are objectives, and there may be constants for these objectives, and these are constants may be of equality type or inequality type. So for equality constants, this power balance and redundancy comes, and then inequality constant, these can be substation capacity, feeder branch capacity, node voltage deviation, and number of DG limits. So we have seen about this constraint uh, in detail in the multi-objective optimization part. So now you can classify this optimization approaches or solution strategy, means what are the means by which we can solve this optimization problem. So this can be divided into 4 types: artificial intelligence based approaches, heuristic based approaches, then meta heuristic based approaches, or mathematical optimization based approaches. In artificial intelligence based approaches, we have Firefly algorithm and fuzzy logic based approach. In heuristic based approaches, we have trial and error method. And in meta heuristic based approaches, we have 2 types: population based meta heuristic solution strategy and unique meta heuristic based solution strategy. In population based meta heuristic approach, that is we call it as multi-point search technique, while unique unique based meta heuristic approach, in that we have point to point search technique. And in population based strategy, we can have evolutionary algorithm, in that we have genetic algorithm and evolutionary programming. Then we have particle swarm optimization and colony optimization, harmony search algorithm, and then artificial V colony. And unique based approaches, we have taboo search, simultaneous annealing. Now in mathematical optimization based approaches, we have deterministic this we call a deterministic based optimization approaches. An example for this are linear programming, quadratic programming, and non-linear programming. Now let us come to this distributed generations. So nowadays this term is quite familiar and quite well used in our distribution networks, is due to the integration of renewable resources, especially this integration of solar photovoltaic. Nowadays we are commonly seeing this photovoltaic in our households, and some plants also installed by the government or some private companies that are feeding power to the uh, that are supplying power to the grid, or that can supply power to the load directly. So how you can define the distributed generation? So there are 2 attributes that are basically used to define the distributed generations, and these are purpose and location. So these the purpose and location are the main 2 attributes by which we are defined the distributed generation. So generation means it is a source of active active electric power. So the purpose is defined. So the purpose of DG is to provide a source of active electric power, while the location of DG is that it should be it should be at the customer side of the meter. So the location of DG is defined as the installation and operation of electric power generation units connected directly to the distribution network or connected to the network on the customer side of the meter. So these are 2 attributes by which we define the distributed generation, and other attributes are not relevant for defining DG, like rating, ownership, type, environmental impacts, power delivery. So you can find this definition of DG in this reference, Ackerman, and all this paper, this article name is distributed generation, a definition. Now let us come to the different types of sources of energy of DG. So DG can be of types of non-renewable type and renewable type. And in non-renewable type, this gas turbine is well known. While in renewable type, we have wind, solar, hydro, geothermal, biomass. And in solar, we can have solar photovoltaic, and concentrated solar power. So these are the types of distributed generation. mainly this non-renewable and renewable. In non-renewable, we have the gas turbine and renewable. These are listed over. These are listed down here. Now the how what do you mean by this distributed energy resources? So the energy resources of DG units are known as distributed energy resources. So you should know about what are differences between distributed generation and distributed energy resources. Now, based on the types of capacity, DG can be of four types, and these are of macro distributed generation. And in macro distributed generation, the range is 1 watt to 5 kilowatt, while in a small distributed generation, the range is 5 kilowatt to 5 megawatt. In medium distributed generation, the range is 5 megawatt to 50 megawatt, and the large distributed generation, that is 50 megawatt to 300 megawatt. So based on the capacity, DG can be of micro type, a small DG type, medium DG type, and large DG type. Now, if you integrate this DG with the power system, there can be two ways. Either you operate in a standalone or you can operate in grid connected. So this DG based on integration with the power system can define as a standalone type or grid connected type. So the name suggests that this standalone unit provides for the greater part of the demand with or without other generators or storage. Means a standalone means the our distributed generation is not connected with the grid, while a grid connected means it is connected with the grid. Means this standalone provides the demand. This standalone type DG provides greater part of our demand with or without the generators or storage. On the other hand, in the grid connected system, a DG unit supplies power to a large interconnected network that is also supplied power by the other generators. So when the DG is connected with the grid, it is simply said as grid connected system, and when it is able to fulfill the power demand of the load, then it can operate as a standalone. So that is a standalone DG, another is grid connected DG. Now the another term we know that is point of common coupling. So the point of grid connected DG is called as point of common coupling, and PCC is the point at which the ownership changes. So you can also point of common coupling is defined as the point at which the ownership changes. Now let us see the typical power network that with DG units. So in this session, uh, mostly the questions are of theoretical type. So we have to we have the good concepts about theory so that you can solve all the problems. So the here, if you see first is the generation. So this is generating plants, and then we have this step up transformer, and these are circuit breakers, and then these are transmission lines and the circuit breakers, and these are substations where these transformers are present. So transformers in bulk power substation, and then we have sub transmission system, and in sub transmission systems, then we have this transformer, and then we have this distribution substation. So at distribution substation we have storage system. So and we have also have solar or wind sources, and the power rating is of 100 kilowatt to 1 megawatt, and dispersed storage and generation. So this can be connected at the this distribution substation, and from the distribution substation we have feeders, means primary distribution network. So we can have our distribution feeders, and that provided to the our households, where this our distributed generations can be connected. So these are all distribution feeders. So here four feeders are, you can visualize, first, second, third, and fourth. So if you see from here, like after the distribution substations, all are part of our distribution system. Yeah, these are the part of distribution network, and these are loads where this service is noted down, and this is distribution transformer. So you can see this DG units with our with our grid. So we have storage system at the substation, while this our DSG, that we call the dispersed storage generations, that are our that that are available at this distribution network. Now coming to this techno-economic and environmental benefits of DG integration. So reduction of environmental pollution and global warming concerns with the use of non-conventional renewable energy resources. We all know that, means like due to global warming and this reduction of environmental pollution, we are moving towards this renewable energy resources, and with the fast depletion of fossil fuel reserves, the use of these non-conventional renewable energy resources is increasingly becoming a requirement nowadays. And DERs usually modular units of small capacity because of their lower energy density, and the dependence on geographical continuous conditions of a region. And the overall power quality and reliability improved due to contribution of the standalone and grid connect operation of distributed energy resources. So the overall power quality and reliability improves due to the integration of DGs available, and the overall plant energy efficiency increases, and also thermal pollution of the environment decreases because of the renewable distributed generation such as cogeneration. So what do you mean by cogeneration? Today we have three people. can go through the SAS lecture also, and here I am just quickly revising all the theory part. Cogeneration is the simultaneous production of electricity and useful heat. So these are the environmental and economic benefits from the DG integration. So these are very easy to understand. Just quickly go through all these points. Now, what do you mean by this active distribution networks? Earlier we are having this passive distribution networks, and now we called our distribution network as active. So what are the things due to which this distribution networks nowadays become active? So our conventional distribution network, or you can call it as passive distribution networks. So there we have no distributed energy resources, and the distributed energy resources capacity for the integration to the existing network is limited. And nowadays we have active distributed networks where this distributed energy resources are more in number, due to which that our distributed management system for advanced control and planning and ancillary services provision. So where we can provide some ancillary services through our DGs, and there is possibility of islanding mode of operation also. Means without grid, we can also have the power supply to the customers. So for this concept, you can refer to this paper, the effect of distributed renewable generation on power system security. So due to the integration of DG only, and this our electric vehicle charging station, nowadays our distribution network become active, and due to which that we can have we can have advanced management system for distribution system, and we can have better planning, and through this distributed energy resources we can provide ancillary services, like we have power factor corrections and many things like that. We can improve the voltage, power quality, and there is also possibility of islanding mode of operation with the active distribution networks. Now, what are the issues in active distribution networks? So if you understand the value of technical benefits and economic benefits, like enhanced security, reduction in investment cost, and reduction in operating cost, there are need of these issues, like these are identify the new control techniques where network reconfiguration and coordination of operation of network control facilities arises. So these are issues why which the occurs due to the active distribution networks, like network reconfiguration and coordination of operation of network control facilities. Now, what are the changes required if you having transition from the passive to active distribution networks? There are reactive protection and control, wide area active control, advanced sensors and measurements, network management apparatus, real-time network simulation, distributive penetration, distributed penetrating communication network, knowledge and data extraction by intelligent method, new and modern design of transmission and distribution system. So if you see the changes mainly in the control side, and then we have communication, and we have also centralized type controller requirement, and we have this designing of transmission distribution system also rises. Now, how you can define the renewable energy penetration? So this is the expression by which we can define the renewable energy penetration. So the average penetration for the renewable energy is the ratio of annual energy from renewable generation in kilowatt hour upon total energy delivered to the loads. So one question in the last year, they have asked based on this average penetration and instantaneous penetration. So this is very simple one. So whatever the energy produced from the renewable generators upon this total energy delivered to the load is equals to the average penetration. So you can also say it like the proportion of electric energy or power being supplied from the renewable sources like wind turbines or PV or another renewable sources, usually referred to as penetration. And next we have instantaneous penetration. So instantaneous penetration means like it is basically the power term. So in the previous expression where average penetration, that is with respect to energy, while this instantaneous penetration, this refers to the power. So instant penetration is the ratio of power from the renewable generators upon total power delivered to the loads. In general, this maximum instantaneous penetration is much higher than the average penetration. So this is important. The maximum instantaneous penetration is much higher, greater than the average penetration. Now, what can be the type of DG units? So DG provides both active or reactive power system. So the DG unit operating at lagging power factor, for example, synchronous generator. So DG it provides active power but consumes reactive power from system. Then DG operates at leading power factor, for example, induction generator. And then if DG operates at an negative power factor, then it is supplying only active power. So it can be of other type of DG units. And then DG operating under voltage control mode, that is with the fixed magnitude. So these are the application based on the active and active power supplied to the system, or based on the unity power factor correction, or in the voltage control mode. So this can be of different type of DG units based on the application. Now the DG integration in the grid can be of plug and play type, and it can support active reactive powers and can improve power quality, and it can handle the fault right through. So this is about our distributed generation. Now we will move to the microgrid concept. So till here, if you have any doubt, you can ask. Otherwise, we can move to the next section, that is microgrid.
One doubt. What is mean by faulted right through?
So we have, I think you know about low voltage fault right through or high voltage fault right through. So if we having means like if voltage goes above certain limit, then your DG should be capable to handle that. So that is the fault right through. It's like at the node and with the DG is integrated. So if the voltage rises or voltage drops, so your system does not become unstable. Your system should be capable to handle that fault. So it can be of many types like LVRT or HVRT, low voltage fault right through or high voltage fault right through.
Okay.
Right?
Thank you, sir. Thank you. This is not related with the short circuit.
Yes.
It is related with the short circuit.
Short circuit. You are asking about short circuit.
Fault right through means it is any relationship between short circuit.
I don't think it is related with short circuit. Means generally it is whatever I know means like we have low voltage fault right through or high voltage fault right through. Means your system should not go in a unstable instability when means some rise in your voltage at the node or some drop in the voltage level. I don't think it is related with your short circuit condition or open circuit condition. Short circuit, I think we should refer some paper if you want to have a detailed discussion about fault right.
Okay.
Whatever I know that means DG is integrated with our means like in some inverter. So your inverter should be capable to handle some like some transition at voltage level. So your inverter should not go means like in an unstable region. Your inverter should be capable to handle the fault like low voltage or high voltage for some part of time.
Thank you.
Okay, Sia.
Okay, got it, sir. Thank you.
Mhm. So now moving to the microgrid concept. So this microgrid is basically an active distribution network, and it is made of a collection of DG systems and various loads at the distribution voltage level. So and these are generally a small low voltage combined heat loads of a small community. And the example of such small community include university or school campuses, a commercial area, industrial site, a municipal region or trade center, a housing state or substation locality. And they can be connected to the main grid or can be operated in islanded mode. So similar to the our distributed generations means it is a collection of DG systems, and distributed generation also can be operated in islanded or grid connection. So whole the collection of DG systems we call it as microgrid, and these operate at distribution voltage level, and connection with the grid it can also two types. One is grid connected mode, another is islanded mode of operation. Now, what are the difference between microgrid and conventional power network? So power generated at distribution level and thus be data provided to the utility distribution system. So in the microgrid, the power is directly generated at distribution level and it can directly provided to the utility distribution system. And they are of much smaller capacity with respect to large generators in conventional power plants. So, so DG are of a smaller capacity as compared to our large generators used in conventional power plants. And they are usually installed closer to customer location so that electric heat loads can be efficiently served with proper voltage level and frequency and ignorable line losses. And they are ideal for providing electric power to the remote locations. So based on the features of this microgrid, these are ideal for providing electric power to remote locations like those in hilly areas especially. And another difference of microgrid with the conventional power network are like the fundamental advantage of microgrid is that they can be treated as controlled entity within the power system. So these can be a separate controlled entity within the power system, and they can meet the electric heat requirements locally, and they can receive uninterruptible power, reduced feeder losses, improved local reliability because they have another power supply at the local end, local voltage support, and another advantage that they reduce environmental pollution and global warming by utilizing low carbon technology. So what are the benefits of microgrid operations? The benefits are improved energy efficiency, reduced environmental concerns and pollution, improving power quality and reliability, improved voltage control, line loss reduction, reducing some operational and investment issues, increasing cost saving, solving market issues, more awareness of customers about energy, increased quality of service, reduced impact of outages. Concerns on microgrid deployment. So what are the concerns if you deploy microgrid? So the concerns are like establishment of standards and regulators are needed so that this microgrids operate in synchronism with the power quality, low energy content of the fuels involved. So these are the concerns of microgrid. The climate dependent nature of the production of DER. We all know that we have solar PV, they are intermittent source of energy, and similar way like wind source, uh, and availability of communication infrastructure, load and generation imbalance, application and control of more polytonic converters, multiple energy source management, and then safety and protection. And also efficient and secure power delivery market scheme, congestion management methods. So line congestion also occurs when there is inefficient transmission capacity to accommodate the electricity demand in a particular area. New ownership and energy providers structures, restructuring roles and responsibility of discom distribution companies and another energy providers and consumers. Now, similar to our DG integration in the power system, we can have structure about the microgrid. So we have uh, so so this is the feeder where from this is connected to the main grid bus, and these are the substation part where circuit breaker and transformer are present. So this is the point where this can be connected to the main grid. So this PCC circuit breaker, and this one is power transformer. So this side is grid and this side is microgrid. Then So this one at the secondary end of power transformer we have low voltage microgrid bus, and then this top one we feeder A we call it as conventional passive distribution network. So feeder A, passive distribution network. So these are MC means these are microgrid. So this is one microgrid that is connected to this feeder B, and these are another microgrid, and this one is another macro. So MC denotes here microgrid. And this SCB denotes externalizing circuit breaker. So in a feeder, generally we have sectionalizing switches, and tie line switches is used to connect the two feeders, two feeder areas. Externalizing circuit breaker. CHP denotes combined heat and power source. So again, this side we have one microgrid. Then this is another microgrid. So there are several microgrids in a distribution networks where these are connected to the primary feeders. Now, what are the different different modes of operation for microgrid?
You mean by
So
CHP?
yes,
CHP, non-CHP and CHP sources.
CHP means combined heat and power,
Fine.
heat and power source.
Okay, okay. Thank you.
So any example of CHP source and non-CHP source?
CHP source means gas turbine.
So then this CHP type source we don't need in India, I think. We generally in the cold countries like European countries, they required both power also and heat also,
Oh, okay, okay.
right? Just I think just confirm with this because heat we don't supply in our country, but if you see in European countries, they also supply this heat
Yes,
to the household. It's like they have connection of means there is no need of geyser and all these things, room heater in European countries. They are being supplied by the utility companies.
like
So
water they are getting also.
yes, they are providing this. They have rod in the household or bathroom anywhere in the totally they are fully ventilated. Means like they when the means hot water goes through this rod and they keep the room warm or means any part of your house or any part of your institute.
Thank you.
Yes. Now for microgrid operations, we have two modes of operations. First one is grid connected mode operation and another one is a standalone or islanded mode of operation. So grid connected mode of operation, the microgrid is connected to the main grid, or it imports, exports power from or to the main grid. While a standalone or islanded mode, we have these are uplanded in islanding conditions, means they are not connected to the grid. And generally what happens that in normal condition they are connected to the main grid, while if any disturbance happened at the grid side, we disconnect the microgrid from the grid and we supply power locally from the microgrid. And this standalone operation happens to the necessary by opening the necessary circuit breakers. Now, what are the components of microgrids? These can be small DG sources and storage devices, LV network, central controller, macro source controller, load controller. So here you can see this is a microgrid example where this microgrid center controller is present, and we have PV based DG here. PV based DG is present here, and then we have battery energy storage system. This is also connected to the inverter. Then we have this micro turbine. I think here is this is a mistake of this converter. And these are local, these are load controller. LC means load controller. And this is MC denotes macro source controller. And this is combined heat power source. Combined heat and power source. So let us see all of these components of microgrid one by one. So first is central controller. So central controller is the main function of central controller includes energy management module and protection coordination module. This uh, central controller includes two controllers. First is energy management module and production coordination module, EMM and PCM. EMM supplies the set points for active and active power output, voltage and frequency to each microcontroller, to each to each micro source controller, and LC load controller to promote technical and economical operation. This is done by advanced communication and artificial intelligence techniques. The PCM protection coordination module supervises the microgrid and main grid faults and loss of grid situations so that power protection coordination of the microgrid is achieved. What are the function of centralized controller, central controller in the grid connected mode? So these can be used for monitoring system diagnostic by gathering information from the micro sources and loads, and this performs a state estimation and security assessment evolution. So central controller performs a state estimation and security assessment evolution, economic generation, scheduling, and active power control with the micro sources and demand side management functions by implying collected information, ensuring synchronized operation with the main grid, maintaining the power exchange at the primary contact points. So this can be in the grid connected mode, while in the standalone mode, this can perform active and reactive power control of the micro sources to keep the stable voltage and frequency at the load ends. These can adapt load interruption, load shedding strategy using demand side management with storage devices support for maintaining power balance and bus voltage. And this can begin a local cold start to ensure improved reliability and continuity of service. This can switch over the microgrid mode connected mode after main grid supply is restored without hindering the stability of the either grid. So the seamless operation of microgrid is one of the uh, research topic. So these all are means like if you see a study means like narrowly each and every point. So these are all problem statements in microgrid, and you can do research in these topics also, like islanding mode operation and this control and this and this seamless operation from a standalone to grid connected and grid connected to standalone mode. These are all research topics.
Any current studies going on regarding this?
Yeah, means there are so many papers. If you can find thousand papers, you can find. Means microgrid is a very broad topic, but if you go inside, means what can be the what can be the what can be the research objectives? Means as far as I know, one is the control side, means like converter control for the DG. One is islanded condition, means like islanded means you can say it as grid forming converter, grid forming or grid forming and grid following converters. Some some converter control they are also defined as grid supporting converter, but they are basically combination of this grid forming and grid following only. And converter control for grid connected operation, and there are many control that operates in both condition, so that is more generalized. And then another topic is islanding detection. Islanding detection is also nowadays too much research is going on this islanding detection in microgrid. And if you see in IT Roorkee through Professor N.P. Pari sir and Professor Pirmalata Jain, Janame, they are doing research on this. They have good papers on this islanding detections. And then as I told you, this seamless operation. Seamless operation of converter or microgrid from islanding to grid connected or grid connected to islanded. Our system should be our system must be in a stable region. Must have means stability the main concern. If your system goes into an unstable region, then that should be the main problem. That should be discarded and that should be minimized. And what can be another thing? Another thing is beyond our power system and power electronics. Another thing here is communication part or
Yeah.
there are
If
many
we
things.
selected this
Yes.
type of topic, then if we select any related this converter control or anything, this is related with the power electronics.
Yeah, power electronics.
Okay, okay. Because power system engineer can do.
Means like what means how I can say means power systems basically you you don't uh, you don't need to design any PCB. But this converter control you can do in this power hardware in loop, or you can do in this there are so many emulators, real time simulations. So this can be easily tested. But if you are not making any converter or from a scratch, then that is not a much like really miss it a mix of power system and power electronics. But nowadays
Yeah.
in power electronics, many people are doing research in this thing. In power electronics, in our institute and many institute I saw, even in IT Madras, IT Delhi, they are doing research on these control aspects only.
Okay.
But they are calling themselves as power electronics engineer.
Thank you.
Okay, so we have 1 hour. Now these are the functions of micro source controller and load controller. So these are these got set point input from the central controller. Micro source controller, they got set point input like from active and active powers, voltage and frequency. They got set point input from the central controller, and they got active reactive generation control of micro sources for energy management applications such as voltage control and economic operation of the system. Interruptible interruptible loads control for voltage control or economical operation of the system. So these are the functions of micro source controller and load control. This is all for theory part, revision section. Now we will move to the questions. So you all, whatever you think means what can be the answer, you type on the chat box. So the first question is that which of the following cannot be an objective in the optimization formulation of distribution network reconfiguration? And the options are minimization of switching cost and service restoration and maximization of number of switching. Minimization of switching cost and number of switching and maximization of service restoration, cost of optimal feeder sizing, cost of reactive power compensation. Yeah, we saying D. D, wrong answer. Any other one?
Should be.
B, minimization of switching cost and number of switching and maximization of service restoration. How B
That is
can be
the
true?
that's the opposite, yeah. Should be A.
Yeah, yeah, A is correct. Here it is asking cannot be. So A is the correct answer. This is the objective optimization function. We require minimization of switching cost and number of switching and maximization of service restoration. And opposite is that minimization of service switching cost and service restoration and maximization number. This is wrong. First part is switching cost is okay. Service restoration is not correct. So this is also incorrect. And this maximization of number of switching is also incorrect. So if we see this objective of optimal network configuration, so minimization of service restoration, maximization of service restoration, Maximization of reliability, that is similar meaning. Minimization of service, it is have similar meaning. Energy loss minimization, feeder load balancing or transformer load balancing, prevention of transformer and feeder overloading, minimizing switching cost and number of switching, maximization of voltage stability index. And these are the optimization objectives in general for distribution system planning. They generally include installation cost of new substation feeder branches and minimization of power losses, minimization of supply interruption, or maximization of reliability. So coming to the next problem, which of the following are advantages of integrating distributed generation in a distribution network?
All of the above.
Yes, all of the above is correct answer. So advantages of integrating DG, like first is enhanced reliability and improved power quality. Yes, reliability improves because we are providing power locally. Power quality also improved. Reduced power flow in the distribution lines. Reduction in the network power losses. So all the above are correct. Answer D is correct. Yes. Dev, your answer for the first question is correct. And yes, you have D is correct. Now this is a little bit lengthy question. Just you have to read carefully. Here they are asking that in which of the option both assertion and reason are correct. I am coming in 2 minutes. The first option is that maintaining voltage levels within a specified limits is not crucial for distribution network unless thermic limit of distribution lines are violated. So this one is incorrect. Voltage level outside the specified range can lead to equipment malfunction, reduced efficiency, and increased risk of electric failure. So this is correct. So overall, this is incorrect. Voltage rail problems become more pronounced in distribution network with a high penetration of renewable energy sources. Yes,
It's correct.
Correct.
yes, it is correct. and region is intermittent, so nature of renewable energy sources decrease the load demand and thus elevate node voltages.
It's also
So
correct.
this does not decrease the load demand. This part is incorrect. This may elevate node voltage due to increased power generation, active power generation, but this is not decreasing the load demand. Load demand is fixed. And then C option, the node voltage deviation in distribution networks are more sensitive to active power junction as compared to transmission networks. Yes, it is correct. The Rx ratio of distribution network is high as compared to the RYX ratio of transmission network. What could be it?
Correct.
Yes,
Yes, reason is correct.
yes, both are correct. So C option is correct. Now let us also see the D option. Node voltage rise violation due to high DG integration can occur only in mesh distribution network, not in retail distribution network. So this is incorrect. Radial networks never allow reverse power flow, thus node voltages are always below the nominal value. This is also incorrect. Therefore, C is correct answer. Now let us see the fourth number of problem.
I have a doubt in the previous one.
Yes.
Because when the consumers are using the solar sources, solar like renewable sources, according depends on this, the load demand may increase or decrease. If they are doing independent solar renewable energy sources, the load demand may increase or decrease. What the point?
Yeah.
Because especially the solar rooftops. So
No. I think here they are. You are correct from your point of view, but I think this is the defined. This here the defined intermittent nature. What is the relation of intermittent nature that decrease the load demand? Here they clearly wrote that due to power supply through renewable, they decrease the load demand. That that statement may be correct. But here they wrote the intermittent nature of renewable energy source decrease the load demand. I think this is the due to this also they this statement got incorrect. But you are certainly true, means like if the household power is getting supplied through their own PV, then they are not demanding the power from the grid. So we have to be very careful while answering this type of problem, because
again, one more thing, we have something called active power injection. This we have something like that. You cannot do only active power injection. Normally we have injecting the normal power. Can have both.
yes, inverter can supply both power, active and active both power.
We don't have. Do we have any system like to injecting only active power?
Means only active power means they are operating at a unity power factor, means like both there is no reactive power generation from the inverter side. Means you are telling
PV,
like that. Yes.
PV can inject only active. PV can inject reactive also.
Means like if you if you have PV is only generating active power, It's true, but if you interface this with inverter, you cannot control the reactive power from the inverter because you are changing the active power into two sources of energy. Means like at the DC we have active power. Yes, true. Means like if you have PV, if you have this PV, here till this part, is there any reactive power?
No.
No, there is no reactive power because the I, but when you have sorry when you have this inverter, you cannot control reactive power from the inverter. Yes, because that's why we say that due to integration of DG we can have improved power quality also because due to DG we can vary the voltage level, we can inject some harmonics also due to this inverter, right?
Yes, yes.
But here if you see means like the natural means like whatever this principle of PV, there is no reactive power generation.
But integration of inverter we can do.
Yeah,
Just like
with the help of inverter only you are telling na, with the help of inverter only you are telling that you are providing the functionalities of DS Statcom, EPQC, DVR, whatever that means. Like they generally they are used for improving the power quality.
see,
So
inside the inverter we will include UPQC or G Statcom like this.
no, means you just explore. But I can say this can provide ancillary services like unity power factor or means improved voltage, improved power quality. So this can provide ancillary services also, not just feeding power to the grid or feeding power to the feeding power to the grid. This can you can you can control this power to the inverter and you can provide some ancillary services or voltage level. Is this clear or not? If somewhere I am wrong, you can tell me.
Yeah, clear, sir.
Yes, means I think those who have asked question, the definition of DG is that they are a source of active electric power. Yes, these are source of active electric power only, but with the having of power electronics equipment, you can vary its you can change its functionalities. Who has asked this question? Yusuf.
It was asked by Shia.
Yes.
Yeah, clear, sir.
Yusuf has asked this question or
No, he was asking. Shia was asking.
In
okay.
case Yusuf is saying.
Okay.
My question was this PV can apply reactive also. That's my question.
The principle is that it generates only active power, but with the integration of power to converters, you can provide whatever you want because it's just like a current source. It's
Yes,
just
yes.
like a DC source here.
That means through integration of this power electronics device in the inverter, we can improve the power qualities.
Yes, so you can what means like what is my reactive power? Reactive power means your current is not in phase with the voltage. That is simple meaning of reactive power. Means when your current is not in phase with the voltage, reactive power is coming. So for the inverter, why cannot have reactive power supply? It is obvious means like whenever the current is not in phase with the voltage, certainly you are providing reactive power. It is very simple.
Yes, yes.
So now let us see the fourth number problem. So these are statements like first, second, third, fourth. Both A and first one is both assertion and reason are true and are the correct explanation of A assertion. And similarly, you can read the second, third, fourth. Now let us see what are the assertion statement and reason statement. Assertion statement that DG integration, not only renewable energy sources in a distribution network, can pose challenges related to a distribution regulation. Reason is the bidirectional flow of power and potential islanding conditions associated with distributed generation require advanced protection and control mechanism to ensure network stability and safety. And for the last problem, I would say that you just go through all the statement, and if you see them, if you see out of them one is most accurate, then pick that one. If you have more doubt in some options.
The answer is one. A.
No, the answer is B. They have given.
Sorry.
So how? In the first statement, they are saying that DG integration can pose challenges to the voltage regulation. Yes, they can pose to the voltage regulation. So I think that the reason should be due to the mismatch in power demand. This can impose voltage regulation, but the reason they have given that different. The bidirectional flow of power and potential islanding conditions associated with generation require advanced protection and control mechanism to ensure network stability and safety. So the reason is also true, but they are diverting from the correct reason.
That is not the reason for A, but it can be a condition for A. To overcome
Yeah,
that, to overcome the issue of in A, we need the reason, but that's not the reason for that pose.
yes, yes. To overcome that, we can we need to apply advanced control mechanism and protection. Also, if
To
we have
overcome that, we
learned
need
about.
this, but it's not the reason for that. Yeah.
Yeah, correct, correct. Very good. Yes.
Sir,
What?
in your
Yes.
institutions, in, okay, Yusuf, continue.
Yes.
Yes, yeah.
You were asking something.
Yusuf, are you asking anything?
No,
No,
no.
no,
I
you're
think
asking. You started asking.
Okay. In your institute, anyone is doing any protection related research in our microgrid?
You're asking the sir?
yeah, one person is. I think in our lab they are doing protection. It's like they are doing. I don't know the clearly topic, but they are having this fault detection and something.
In microgrid.
Yes, yes, in microgrid. AC side fault, DC side fault. They are doing that.
Mm-hmm.
You can his name is Lakshmikant Rao. I think you can refer to our college website also.
Lakshmi?
Lakshmikant Rao.
Okay. He is a research scholar.
Yes, yes, he is a PhD student.
Okay. Okay, thank you, sir.
Okay, let us see. Come to the fifth number problem. Which of the following statements is true about the static planning and dynamic planning of power distribution network? So the options are static planning only considers load growth, while the dynamic planning considers load growth as well as addition of new nodes into the existing distribution network. B option is both static and dynamic planning consider expansion planning, while as dynamic planning also consider load growth in the network. C option is static planning is a one-step planning which considers peak demand in the existing distribution network, while the dynamic planning also considers future load growth as well as expansion planning. A static planning only considers the addition of new nodes in the network expansion planning, while as dynamic planning considers peak load demand as well as future load growth.
In C.
Yes, very good, sir. See the correct. If you see the distribution system planning, this can be of two types. First is static planning, where load growth is not considered, and in this we consider peak demand in the existing distribution network, and it is one-step planning. While the dynamic planning, here load growth is considered, so load growth is in existing network, and or it can be of addition of new nodes, that expansion planning. So in the first statement, if you see, so here they are telling that considers load growth. So here itself it is incorrect. So both node considers expansion planning, only the dynamic planning consider expansion planning. And D option consider the addition of new nodes. No, does not consider the addition of new nodes. So let us see the sixth number problem. Which of the following forms of renewable energy holds maximum share in installed capacity in India? It is a general knowledge type problem.
Wind.
Yes?
Wind energy.
No, wind is not correct. So wind energy is, I think, in southern part of India is abundant, but in northern part we don't have wind energy.
Then option is B. Solar.
Yes, solar energy is correct.
But
You
I
can
think second
yes.
in Asia we have second India having wind energy.
So we have to go to statics. You can Google it, means like now.
But you mark now it is wrong.
Oh, sorry. Solar energy is correct. That will search on Google itself. See, but they're showing wind more. But the data are changing. And
Yes, yes.
so here, if you see this solar power is 45.1%. We have to go to some authentic website. Here 92.12 gigawatt till 2024 solar energy, and wind energy is 47.72 gigawatt for wind energy.
Okay.
Major are this Rajasthan, Gujarat, Tamil Nadu, and Karnataka. Anyway, come to the next problem. So next problem we have, how does the implementation of distributed generation contribute to grid resilience from a techno-economic perspective? And the options are by increasing energy losses, by reducing the need for grid maintenance, by providing backup power during grid outages, by decreasing the need for energy storage.
See,
No, C is not correct. So if you see, you have then there are more chance of doing mistake in the theoretical problem only, because they provide options somehow little bit confusing. I means honestly I am, it's like realizing this thing. They don't put
yes.
easy options for theoretical part. Be careful while solving the theoretical question, because in numerical problem whatever answer you get, they will put certainly one option only, and they will not provide some means whatever you, if you do mistakes in getting like get exam, they will don't put numerical type question is like more chances of getting corrected in NPTEL exam.
Is it D?
I person I personally think so. Yes, D the sorry. Sihab, you were correct. C the correct. I didn't got. I didn't read the question. C the correct. Sorry. By providing the backup power during grid outages. Yes. Here they are asking about grid resilience. Yes. So they are providing the resiliency by providing the backup power during grid outages. It is not correct by decay. Sorry. You were correct. C the correct answer. Energy storage anyway, this is no relation. They will not decrease the need for energy storage. Now, eighth number problem, which of flowing can typically be range for the power generation capacity of medium distributed generation units. And the options are 5 kilowatt to 50 kilowatt, 5 megawatt to 5 gigawatt, 5 gigawatt to 50 gigawatt, and D is 5 megawatt to 50 megawatt.
In our class, we discussed that before.
What?
In our class, we discussed this.
Okay, okay. So you can cut this paste over there. So medium distributed generation, that means 5 megawatt to 50 megawatt. So for micro, 1 watt to 5 kilowatt, then small 5 kilowatt to 5 megawatt, and then medium 5 megawatt to 50 megawatt, and then large 50 megawatt to 300 megawatt. Now come to the second last problem. A distribution network with peak load demand of 3.5 megawatt is integrated with installed renewable power capacity of 2.8 megawatt. The total energy supplied by the renewable sources over a year is 9.10 gigawatt hour with average penetration of 52%. At a given time instantly, the renewable energy power supply 2 megawatt out of the total 2.7 megawatt load demand. Determine the instantaneous penetration at time instant and total energy supplied to the load over a year. So here we require two expressions. So we have already seen that. So first, let us find the instantaneous penetration. Instantaneous penetration. Instantaneous penetration is power from renewable generators. Power from renewable generators upon total power delivered to loads.
The answer is A.
Yes, correct. Very good. A is correct answer. Total power delivered to loads. So this is given here over here. It is saying that
Instantaneous generation equation is different. Is kW divided by kW. Average penetration is in kWh. As per
So
your
here
slide.
2 megawatts divided by 2.7 megawatts.
Yes.
I am saying this instantaneous penetration equation is wrong as per our slide. Okay. If it is KW, is okay.
Yes. Sorry. So here they are given renewable source supply 2 megawatt out of the total 2.7 megawatt. So this is 2 upon 2.7 megawatt. So it will be 0.7407 or 74.07%. Now yearly load consumption you can find from the average penetration. So average penetration yearly they have also provided. So average penetration annual energy from renewable generators upon total energy total, that is yearly load consumption only, total annual energy delivered to loads or megawatt can also be correct. So, so it will be early load consumption. You can write early load consumption. So annual energy from the renewable generators is over here is 9.10 gigawatt hour. While average penetration is 52%. So it will go downside 0.52. So it will come as 17.5 gigawatt hour.
I did it in a different way. I multiply by 2 into 8760. 2 megawatts is the instantaneous penetration. 2 multiplied by 8760.
Okay, 2 megawatt is the
Instantaneous penetration. And for 1 year, 8760 hours.
so you're getting same answer.
Yes.
1 minute. Not exactly same. It is 17.5. This is the correct way. That my and here the data is little bit means like you are getting correct from that way, but that is not correct way because this is the instantaneous power. You cannot multiply with because you don't know the average penetration. So it should be the followed for average early load consumption of the loads with the help of average penetration. You are getting 17.5, right? Not 50.
Yes.
Yes. Now let us see the last problem. So which of the following can you present in the conventional radial distribution network? In the options are bidirectional power flow in the feeders, grid integration of renewable energy sources, grid integration of renewable sources as well as bidirectional power flow in the feeders, neither grid integration of renewable sources nor bidirectional power flow in the feeders.
Is it B?
Yes, B the correct answer. Why cannot we see? See how? Which thing?
Because there is
Yusuf?
not bidirectional in the radial. It is in the ring only bidirectional.
Okay. B the correct answer. So any other thing you want to ask? Otherwise, we can close today's session and you can refer previous year, means like 2023 problems and 2022 problems. I have attached here.
Thank you, sir.
Any other thing you want to discuss? Otherwise, we will close today's session. In the next session, I think we need to study about wind energy system.
Yeah, I have seen the questions mostly from wind energy.
Yeah, not worry, we will study in detail.
Okay. Thank you, sir.
Okay. Thank you for attending session. There we will meet on the next Sunday. Thank you for joining. Good night, everyone.